So this one is the pop quiz 2 of IGCSE physics. The topics related to this pop quiz: time period, motion, Hooke's law, mass, weight, and density work. In the first question, a student investigate a pendulum. He measure a time for 20 oscillations. So this is a time for 20 oscillations. He repeat the experiment 3 more times. As you can see, what is the average period? So first, this is a time for 20 oscillation. What we have to take, we need an average time period. So first, what will be the time period? Because 17.6 is a time for 20 vibration. So time for one vibration will be 17.6 divided by 20, which is equals to 0.88. Then it will be 19.8 divided by 20. So we'll know how much time to complete one oscillation. The total time divided by number of oscillation, that will be 0.99. Then we have 17.6. So again, it will be 0.88, and 18.6 divided by 20, that's equal to 0.93. So these are the time intervals, time to time period. But we need an average. So how to take an average time period? What we simply do, we will add all of them and divide it by the total number. So if you want an average of the four values, so we have in 0.88, 0.99, 0.88, 0.93, add them all and divide it by 4. So when you take an average, it will give you 0.92. So B will be the right answer. Is it clear? So we take this, first we find the time period, time to complete one oscillation. And then this time period is we take an average of the four values, we just add them and divide it by total number. Moving on to the next question. A car joins a road at a speed of 14 meters per second. That's the starting speed of the car, U. The acceleration of the car, the change in speed every second is 4. That's an acceleration. And it accelerates for 5 seconds. We need the final speed. What formula we will use? We will use a formula that acceleration is a change in velocity divided by time. What is the acceleration of the car? That is 4. The final speed we don't know. Initial speed is 14 and the time interval is 5. So this 5 is divided, other side will be multiplied. So 4 multiplied by 5 will be 20. So 20 equals V minus 14. Then 14 is subtracted here, other side it will be added. So it will be 20 plus 14 is equals to V. So 20 plus 14, that's equal to 34. So option D will be the right answer. Is it clear? Question 2. In question 3, a metal wire is loaded up to limit of proportionality. So if we have a graph between force and extension, so it will be a straight line. The last point where this line is straight and it follow the Hooke's law, that point is known as limit of proportionality. And if we, beyond this point, it won't follow the Hooke's law as it crosses the limit of proportionality. Force and extension are not directly proportional. So if we check the options, Hooke's law, what is the Hooke's law? It states that force and extension are directly proportional. Hooke's law is not obeyed when the load is increased from 0 to this point. Not 0 to this point, like till the limit of proportionality, it obey the Hooke's law. It follow the Hooke's law. So this statement is not correct. When we check, when a load is increased beyond the limit of proportionality, the diameter of wire will increase. No. When, if you, logically what happened, if you add too much load, like example, if this was a wire is there, if we add too much load, what will happen? The wire will stretch and its diameter, its length will increase and the area or the cross-section area will decrease. It get thinner. So its diameter does not increase, its diameter will decrease. Like when you stretch, like example, say you have a rubber band in your hand and you're stretching a rubber band from both ends. What you will find when you're stretching a rubber band from both ends, the rubber bands start to reduce the diameter, the thickness. So it won't increase, it will decrease. So that's why B is not correct. When we check C, when a load is removed, the wire will return to the original length. That's true. Like if we return, like if we remove the load, as we know, force and extension are directly proportional to each other. If we increase the force, extension will increase. If we decrease the force, extension will decrease, and eventually it will return back to its same original length. So option C is a valid answer. Why not D? Up to limit of proportionality, there is no change in shape of a wire. That's wrong because the wire will stretch. So there will be a change in shape or there will be a change in length. So this one is not correct. Because if you are applying a load or a force, the object will stretch. But here option D state that it does not stretch or it does not change the length, which is totally incorrect. Is it clear? Question 3. In question 4, student carries out an experiment. So a student is finding the density. Which two measurement does the student need to determine the density of a rock? Look, if we want to determine the density, how we can determine or find the density? Density is mass divided by volume. So we need the mass of a rock. 200 gram is the mass of the container, the measuring cylinder plus liquid. And this is the mass of a measuring cylinder, liquid and the rock. So how I will know the mass of the rock? So how much the mass has increased, that is actually a mass of rock. Like 200 gram was liquid plus measuring cylinder and 264 gram is liquid, measuring cylinder and rock. So how much it has increased? It increased by 64 gram. So what is the increase in the mass? That is what we need here for increase in mass, measurement 1. And what about the volume? How much the volume increases? Because how much the volume changes, that is refers to the volume of the stone. Like when we add this stone, how much the volume changes, that will give us the volume. Say originally say it was 30 centimeter cube and then it changes to 40. So what is the volume of the rock? The volume of the rock will be 10. Like how much increase in volume? So we will use increase in mass and increase in volume to know the density of this rock. So A should be the right answer. Like how much the mass increases and what is the change in the volume or the volume increase. Mass increase divided by volume increase will get the density of this rock. Is it clear? The next one, the gravitational field strength is 8.8 Newton per kilogram on Venus and it is 3.8 Newton for 1 kilogram on planet Mars. An object is having a weight of 42 newtons on Venus. What are the masses and what will be the weight on the Mars? So how you can work out this? You have the formula weight is equals to mass multiplied by gravity. So weight on the Venus is 42. Mass we don't know. And what is the gravity of the Venus? The gravity of the Venus is 8.8. So we need the mass. So it will be 42 divided by 8.8, which is 4.77, which is you can round it off to 4.8. So mass will be equals to 4.8 and the unit will be kg. And we know the mass of an object does not change. So if its mass is 4.8 kilogram on Venus, it will also have the mass of 4.8 kilogram on Mars. So mass will be 4.8 because the mass of an object does not change as we move from one place to another. It's amount of matter. But what about the weight? So weight depends on the gravity as well as the mass of an object. So mass is 4.8 and the gravity of the Mars is 3.8. So 4.8 times 3.8, which is equals to about 18.24. So if we round it off, it will be about 18 Newton. So 18 Newton will be the weight and the mass will be same as the mass on the Venus. So option A will be the right answer. Is it clear discussion?